Welcome back, everybody. Our next problem says, provide the Lewis structure of the given NH₄O+. So we have our molecule here. It has a nitrogen, 4 hydrogens, an oxygen, and an overall +1 charge. So what are the steps we go through to try and come up with the best Lewis structure? Well, first of all, we're going to look at the total number of valence electrons in the entire molecule. So total valence electrons, so I'll put E negative. With nitrogen, nitrogen has 5 valence electrons. So I'll just put a little 5 up here. Hydrogen has 1 and oxygen has 6. So for the total valence electrons, we have 1 nitrogen, so 5. We have 4 hydrogens, so 4 multiplied by 1, plus 6 valence electrons from the oxygen. So we have 5 plus 4 plus 6, 15 from our atoms, but we have this +1 charge. So we have to add 1, +1 charge, but that means we're missing an electron. So let's note that because that's important. Missing 1 electron. It's easy to mix those things up, as I just did. So we don't add 1. It's not a total charge. It's a number of electrons. So subtract 1 since it's missing 1. So we have 14 valence electrons. So we know that overall, when we finish our structure, it needs to have 14 valence electrons. So the next step is we draw a sigma bond framework. So posit how these might be connected by single bonds. And then we modify it based on how many valence electrons we have and the stability of certain arrangements. We know that hydrogen will only form 1 bond. We have 4 hydrogens, 1 nitrogen, and 1 oxygen. So let's put the nitrogen and oxygen together with a single bond. So NO. Since hydrogens can't carry more than 1 bond, we wouldn't end up with any hydrogens being internal. So we know the nitrogen and oxygen must be bound to each other. So we could have a structure where, say, there are 3 hydrogens on the nitrogen and 1 hydrogen on the oxygen. So let's try that. We could also try a structure where nitrogen bond to oxygen, where each of these has 2 hydrogens. Now, what about a structure where nitrogen has 1 oxygen, and nitrogen has 1 hydrogen, and oxygen has 3? Well, hopefully we remember that oxygen is usually most comfortable with 2 bonds. We know there are compounds where nitrogen takes 3 hydrogens as well as a 4th bond, but the idea of oxygen taking 4 bonds is just very unusual. So unless we have some reason where we'd need that as a potential structure, we won't worry about that one. So let's evaluate these two. So first, let's look at the total valence electrons in each of these structures. Does it match what we need? So from structure 1, with the 3 hydrogens on nitrogen, let's count the number of valence electrons. So first we need to know how many are here based on the sigma bonds, and that will let us know if there's any lone pairs that need to be placed, keeping in mind that the whole molecule should have a +1 charge. So I have, first count the total number of bonds. So I have 1, 2, 3, 4, 5 bonds. So 5 bonds multiplied by 2 electrons equals 10 electrons in bonds, so 10 bonding electrons. And we need a total of 14. So that means we need 4 electrons that are left over. So we'll need 2 lone pairs. Well, nitrogen isn't going to take on any lone pairs. It's already got 4 bonds. But here's our oxygen with 2 bonds, and it's quite happy to take 2 lone pairs to give us our 4 leftover electrons. So there we have 14 valence electrons. Do we have a +1 charge? Let's calculate the formal charges here. All these terminal hydrogens, 4 of them, have just 1 bond and 1 valence electron, so they have a 0 formal charge. Let's look at nitrogen. its formal charge, Fc, equals its number of valence electrons, so 5, minus its number of non-bonding electrons, which is 0, no lone pairs here, minus its number of bonds, which is 4. So we get a positive 1 charge on the nitrogen. So we'll just put a plus by our nitrogen. Then the oxygen, in this case, its formal charge equals, we know oxygen has 6 valence electrons, minus, there's 2 lone pairs, so that makes 4 non-bonding electrons. And it has 2 bonds, so minus 2. So we have 6 minus 4 minus 2 equals 0. So oxygen carries no formal charge here. So that's one potential Lewis structure with a positive 1 charge on the nitrogen and 2 lone pairs on the oxygen. Now let's see how our other Lewis structure works out. This would be the one with nitrogen and oxygen bonded in the middle, and each of those carrying 2 hydrogens. So first of all, the total valence electrons. We have 1, 2, 3, 4, 5 bonds. 5 bonds multiplied by 2 electrons in each bond equals 10 electrons. Just like in our other structure, that means we have 4 electrons left over, which will equal 2 lone pairs. Looking at our atoms here, nitrogen and oxygen each have 3 bonds each, so let's put a pair of lone pairs on each of those. So lone pair on nitrogen, a lone pair on oxygen. So now we have 10 bonds, or 10 electrons in bonds, plus 4 electrons, giving us 14 valence electrons for the molecule, which is correct. So now let's just figure out the formal charges. The hydrogens all are terminal with 1 bond, so they have no charge. Nitrogen, its formal charge, equals 5 valence electrons. It has 1 lone pair, so minus 2 non-bonding. There's 3 bonds, so minus 3 bonds. So 5 minus 2 minus 3 is 0. So no formal charge on this nitrogen. Then for oxygen, its formal charge, there are 6 valence electrons, minus, there's a single lone pair, so minus 2 non-bonding, 3 bonds, so minus 3. We have 6 minus 2 minus 3, leaving us a formal charge of positive 1. So in this structure, the positive charge is on the nitrogen. So now we've got 2 structures that have the right number of valence electrons. Which one is going to be our correct Lewis structure? Well, the difference is the first one has a positive charge on nitrogen, the second one has a positive charge on oxygen. Well, the first one's going to be our structure because it will be more stable. And that's because nitrogen is less electronegative than oxygen, so it's going to be more comfortable with a positive charge. So we'll say oxygen is more electronegative and therefore less stable with a positive charge. So with that in mind, our Lewis structure of our given ion, NH₄O plus, has nitrogen with 3 hydrogens, a positive charge and a bond to an oxygen. That oxygen has 2 lone pairs, and it's bound to a hydrogen. So again, that means that the positive charge is on nitrogen. In this case, a more stable arrangement than the alternative one we drew. And hopefully this video helps, and we'll see you in the next one.